Welcome to Spelling Bee Ninja's educational series. If you're eager to understand the amazing world of mathematics and its role in our everyday lives, you've come to the right place. Join our community of curious learners as we explore important concepts that empower us to make sense of the world. Make sure to subscribe for more enriching lessons on mathematics and beyond, delivered right to your ears, absolutely free. Today, we're diving into a fascinating topic: the relationship between speed, distance, and time. These three measurements play a crucial role in describing movement, whether it's how quickly you can walk to school or understanding the vast distances covered by spacecraft. Let's start with the fundamental relationship that ties these quantities together. The connection is simple yet powerful and can be summarized by the formula: speed equals distance divided by time. This means that if you know any two of these values, you can calculate the third. For instance, if you know how far you're traveling and how fast you're going, you can determine how long the trip will take. Conversely, if you're aware of the speed and the time taken, you can find out the distance traveled. This relationship is not just a math exercise, it impacts daily decisions like planning a road trip or knowing when to leave for an appointment. It has even been used for centuries, with ancient sailors using similar calculations to estimate their travel times across the seas. Understanding this connection is foundational for anyone looking to grasp the basics of motion. Let's delve deeper into calculating speed in real-world situations. To find speed, you take the total distance traveled and divide it by the time taken. The units used can vary. For example, you might measure speed in kilometers per hour if you're driving, or meters per second if you're running. Here's an example: suppose you drive 120 kilometers in 2 hours. By dividing 120 by 2, you find your speed is 60 kilometers per hour. Now consider running 100 meters in 10 seconds. That calculation gives you 10 meters per second, which you can convert to kilometers per hour, approximately 36 kilometers per hour. Understanding how to calculate speed isn't just educational, it helps monitor driving speed for safety, track performance in athletics, and even comprehend how quickly things move in the world around us. Did you know the fastest speed ever achieved by a human-powered vehicle is around 144 kilometers per hour? This record was set by Denise Muller-Koronek in 2018 on a bicycle. Now that we have a grasp on speed, let's see how distance is calculated when you know speed and time. The formula for distance is simply speed multiplied by time. For instance, if you travel at a speed of 60 kilometers per hour for 3 hours, you can calculate that you covered 180 kilometers. Or, if you walk at 5 kilometers per hour for half an hour, you can easily calculate that you've walked 2.5 kilometers. This calculation proves vital in many areas of life, such as in trip planning: how far can you get in a certain amount of time? In athletics, it determines how far a runner or cyclist has gone. Navigation also relies on it, helping us calculate our positions accurately. Speaking of distances, let's not forget that the Earth travels around the Sun at an astounding speed of approximately 107,000 kilometers per hour. Over the course of a day, that's nearly 2.6 million kilometers. Now, let's shift focus to how we calculate time when we know the distance and speed. This is equally straightforward: you take the distance and divide it by the speed. If a trip requires 240 kilometers to be traveled at a speed of 80 kilometers per hour, you'd find the duration by dividing 240 by 80, which equals 3 hours. Suppose you want to walk 10 kilometers while moving at a speed of 5 kilometers per hour, you would find that this will take 2 hours. This knowledge is essential for planning how long it will take to reach various destinations, whether for personal travel or logistics. Transportation planning often utilizes these calculations to ensure efficient scheduling. The Concorde supersonic jet, for instance, could fly from London to New York in just 3.5 hours, which is less than half the time it takes a regular plane. Now, let's explore how different speed measurements come into play when we examine transportation across various modes. Each method of transportation operates at different speeds, which are crucial pieces of information when planning a journey. Walking averages about 5 kilometers per hour, while cycling can range from 15 to 20 kilometers per hour. Cars travel between 50 to 100 kilometers per hour on highways, while trains can reach up to 300 kilometers per hour, and airplanes typically cruise around 800 to 900 kilometers per hour. Spacecraft, on the other hand, reach an orbital velocity of around 28,000 kilometers per hour. When planning how long it will take you to travel a specific distance, knowing typical speeds helps you make informed choices. For example, a 100-kilometer trip takes around an hour by car but can take over 6 hours by bike. It's interesting to note that the Boeing 747, which is one of the fastest commercial airliners, flies at about 920 kilometers per hour. To illustrate this further, a trip from New York to Los Angeles, which is roughly 4,000 kilometers, will take a standard commercial flight about 5 hours, compared to the 40 hours it would take if driving. Next, let's consider how speed is measured and utilized in athletics and sports. Speed is not just a number, it represents excellence in performance. In track and field, races like the 100 meters are measured down to fractions of seconds, and in cycling, average speeds during races are crucial for determining the winner. Various sports capture speed metrics, with sprint runners aiming to improve their times. Usain Bolt, for example, completed his 100-meter sprint in an astonishing 9.58 seconds, averaging around 37.6 kilometers per hour. In team sports like soccer and basketball, player speeds influence how strategies unfold on the field. Understanding speed allows athletes to train effectively, coaches to make real-time decisions, and fans to appreciate remarkable performances. Speaking of which, Usain Bolt reached a top speed of about 44.7 kilometers per hour during his record-breaking run. That's faster than many cyclists. Now let's explore the difference between average speed and instantaneous speed. Average speed is the overall distance divided by the overall time taken for a trip. Instantaneous speed, however, is what your speedometer displays at that particular moment. Consider a road trip with frequent stops. Your instantaneous speed might be varying from 80 km per hour on the highway to 30 km per hour in the city and dropping to 0 km per hour at red lights. Due to these variations, your average speed for the entire trip might only be 45 km per hour. Understanding both types of speed enables a more precise analysis of motion and helps us interpret speed-related information accurately. Interestingly, modern speed cameras measure instantaneous speed, capturing your speed at the exact moment you pass them, which explains how drivers can be ticketed for speeding even when their average speed seems fine. Finally, we can wrap up our lesson by looking at how speed plays a vital role in science and nature. Speed is a core principle in various scientific fields and is evident in nature. For example, light travels at approximately 300,000 kilometers per second, the fastest speed in the universe. Meanwhile, sound travels at about 340 meters per second in air. From animals sprinting, like cheetahs reaching 120 kilometers per hour, to the slow crawl of snails, the variety of speeds in nature is astounding. In physics, speed helps explain motion, energy, and force, revealing how things react in our environment. Speed also influences survival strategies in biology and significantly affects weather patterns in earth sciences. By understanding the concept of speed as it applies to the world around us, we deepen our appreciation for its vast implications. It's fascinating that at the speed of light, you could circumnavigate the Earth 7.5 times in just 1 second. The calculations of speed, distance, and time are fundamental elements of daily life. We use them to plan our commutes, create travel schedules, and ensure safety with appropriate speed limits. They also underscore logistical efficiency in shipping, the reliability of emergency response times, and key performance metrics in sports. These mathematical concepts equip us with the skills to manage our time effectively, make informed decisions, and understand our surroundings. It's clear these skills serve as practical tools, applicable in many areas of our lives. Today, we've explored the essential relationship between speed, distance, and time, uncovering how these concepts interplay in daily life in various fields. We've looked at how to calculate speed, determine distance, and estimate travel time. We've also seen how athletes measure speed to enhance performance, and how these calculations play a significant role in transportation and safety in our lives. From the Earth's orbit around the Sun to a runner's sprint, speed is a concept that resonates throughout nature and science. Thank you for joining us on this journey through the math behind movement. We hope this exploration has inspired you to see the connections between mathematics and the world around you. Remember to subscribe to Spelling Bee Ninja for more engaging lessons that will deepen your understanding and sharpen your skills in math and beyond. Until next time, keep exploring and stay curious.